I'm introducing a binary classification problem to you. What are the points just in time? These are all ones and these are zeros. That's it. That's a binary classification problem. So you, let's say we start with linear classifiers. Let's say we want to use a linear classifier to classify this. Obviously, no line is going to separate this. Yes? A linear classifier, or let's say logistic regression, or what any linear classifier, let's say it gives f of x belongs to, let's say 0 and 1. After thresholding, जो भी हमने thresholding बीच में set की हुई है, जो value आएगी या वो 0 देगा या 1 देगा. 0 means it is 1. This the particular point is, let's say, on left side of the line, and 1 means it is on the right side of the line. Let's say where there is an interpretation of left side and right side of the lines. Yes, make sense? Now, if this is a separator, let's say, so for all these points, the value of the separator is 1, and for all these points, the value of the separator is 0. Yes? Yes? Because all these are on this side, and all of these points are on this side. Make sense? Yes, no?
Yes.
Okay. If I have another separator, then all the points on this side, they are 0, all the points on this side, they are. Yes? If I have this separator, then all the points on this side, they are 1, all the points on this side, they are 0, on this line. So this separator is doing error on these points. This separator is doing error on some points. Every separator is doing error on some points. Yes? And if I have this separator as well, yes? Then all the points that are on this side
Are zeros.
are. Make sense?
Yes.
Now you can see this is a boundary. So if I call this separator as F1 or line 1, this separator as F2, this separator as F3, and then F1, F2, F3, and this separator as F4, then here is the rule to classify. If F1 and F2 and F3 and F4 is 0, if the and of this, if this is 0, I'm sorry, if this is 0 and or, let me call it or. How can I quote that they all should be 0? They all should be 0. अगर कोई एक वन होगा मैं भी टोटल is equal to 0. So if this or this or this, if that is 0, that means the point belongs to class 0. Otherwise the point belongs to class 1. Yes, no?
Yes.
Okay. Fine.
Make sense?
Yes.
Makes sense.
Yes, no?
Yes.
In this particular case, if f1x, f2x, f3x, f4x, if all of these is 0, then x belongs to class 0. Otherwise it belongs to class 1 in this particular case. So you can now see, I can combine linear classifiers in particular way to achieve a non-linear boundary. By just combining them with ORs and ANDs. I can come up with a different boundary by combining some ORs and some ANDs. Yes, no?
Yes.
If I assume a linear classifier in this case, not just linear classifier, any binary classifier. I'm focusing on linear classifier because in neural networks, each component will be a kind of a linear classifier. I will show you that a soft version of that. Make sense? If you have a binary classifier, in particular, अगर मैं non-linear classifier हो तो पहले से ही नजर आ रहा था कि यार I am going to draw some non-linear boundary. All I am going to tell you, you can come up with non-linear boundary by linear boundaries, but combining a lot of those. You can come up with, if you use a lot of lines, you can come up with circle. Circle is a very non-linear boundary, approximation of it. Make sense? Or some function that is very scary and non-linear. You can approximate that by choosing a lot of lines and then combining the lines with using ands and ors and stuff like that. Yes, no. That's the motivation. If you have linear functions, a lot of those, each linear function is doing something else, then you can combine them together to come up with a very complicated boundary.
Sure.
Yes, no. And that combination, for now, I'm showing that the combination will be taken by ands and ors because the output of each linear classifier is 0, 1 bit. So you can combine 0, 1s by using and, or, not and, else, or, depending on what boundary you want to make. Yes, no? Make sense? Yes, makes sense. Okay.
सही कि अगर चारों क्लास में 0 तो क्लास 0 से ड्रॉ करता है
Yes.
अगर कोई एक भी 1 है तो क्लास
वो क्लास 0 से नहीं, which means वो 1 से. Yes? In this particular case. अगर कोई एक भी classifier कहता है कि this is 1, then this point is not a class 0 point. In this particular case, we can come up with another rule. Let's say we have सबका and मैं इसको शायद इस तरह से इंटरप्रेट करूंगा. नहीं कह सकते. नहीं, मैं कहूँगा इसका negation अगर 1 है, अगर इसकी negation 1 है, तो फिर class 0 नहीं, ऐसा ही. अगर सबका and 1 है, नहीं हो रही है, देखना पड़ेगा. अब तो हम लॉजिक में हैं, अब तो हम कॉम्प्लीमेंट लेना है, सारे कॉम्प्लीमेंट ले. You can see that. सही है. Let me give you one more intuition, and I want you to come up with the classification boundary. Yes? No line is going to classify this quantity data. Yes? I'm assuming two-dimensional data. Let's say I have this line. This is F1. Yes? And this is, let's say, the left side of the left side, and this is, let's say, the right side. Sahi? But right side means on this side, अगर कोई point इस side पे होगा, it will always give 1. अगर कोई point इस side पे होगा, it will always give 0. Yes? And then let's say I have ऐसे या ऐसे
यहाँ से तो बराबर है. ऐसे तो दोनों साइड पे आ रहा है. ऐसे करने को.
Here? This one? No, sir. Yes. Let's say this is another line. Wherever we want. Let's say this is F2. And assume this is
0.
left side and this is right side.
Right.
By left, I mean this is the 0 side. This side होगा तो 0. Let me call this 0. And this is the side 1. And this is again the side 1. And this is the side 0. Can I use F1 and F2 with ands and ors? And can I come up with a rule that 1 का होगा और 0 का होगा? For example, this should be classified as, this point should be classified as 1. So for this particular point, it should be on the right side. So it should be F2 इस पे 1 generate करे और F1 भी इस पे 1 generate करे. Yes? It looks like ये दोनों इस पे 1 generate करे. इस पे ये 0 जनरेट करे, ये 1 जनरेट करे. Yes? इस पे
F1 0
दोनों 0.
ये 0
नहीं ये 1 था. नहीं ये भी 0 था.
और ये भी 0.
Yes.
Okay. इसका मतलब अगर दोनों 0 है तो क्लास 0 है. अगर दोनों 1 है F1 जो है वो 1 जनरेट करे और F2 0 जनरेट करे तो फिर दोनों क्लासेस आ रहे हैं। Make sense? So ये क्लासिफायर सही होगा। Can I place the second line in a way? ये सारे क्लासिफायर हो गए। I want to use two lines. I have one line that separates this and that.
दरमियान में क्रॉस नहीं यार पैरेलल करने
दोनों पैरेलल करने okay first of all see that using these two lines I cannot come up with ends and or that can classify
yes
no yes so can you come up with another line
I need two parallel lines parallel is not okay
let's say that this one
एक लाइन ऐसे होगी एक लाइन ऐसे होगी हाँ जी बिल्कुल एक ऐसे होगी
नीचे जाना
हाँ जी वाले एक ऐसे होगी
दो लाइन दो कैंडिडेट सीधी में
दो लाइन लगी
let's say ये लाइन मैंने लगाई है ये लाइन लगी है
इसके पैरेलल में एक और लाइन चाहिए
ऐसे
हाँ जी हाँ ओके
with what this is
ऊपर 1 नीचे 0
okay this is 1 and this is 0
yes
okay so now using these two lines I have if both are 0
it's
दोनों का एंड अगर 1 है तो 1 है
if F1 gives 1
and
and F2 gives 0 then we have
0
0 if F1 gives
1 and F2 also gives
F1 gives 0 and F2 gives 1 और ये दोनों नहीं कर ये डेटा पॉइंट्स हैं
अभी दोनों करंट लेने से दोनों बहुत अच्छे हैं
अगर दोनों 1 हो अगर F1 भी 1 हो F2 भी 1 दे तो 1 है मतलब okay if F1 and F2 if that is 1 then the class 1 otherwise class 2
yes
will this stay the same if I have this one here
no
can I do this by two lines
No.
I can redraw the two lines can I come up with the rules by two lines if I cannot then I will introduce a third line but tell me two lines that do this
एक ऐसे चला
does it
एक ऐसे दो लाइन
does it
नहीं ऐसे
दोनों
वन के साथ एक सीधी लाइन
ऐसे
ऐसे बड़े बेस वन के साथ
एक और पैरेलल
एक और
पैरेलल
सिर्फ 1 है
ऐसे
this is 1 can I do this with two lines
मैंने जीरो भी ऐड नहीं करते फिर भी करते
sorry
मैंने जीरो ऐड नहीं करते फिर भी करते फिर ठीक जीरो वो जीरो
वो खत्म भी हो गया
अगर तो मान लो 1 ये F1
ये इस साइड पे 1 है इस साइड पे 1 है
अगर एक 1 दे तो एक जीरो दे देंगे
तो
नहीं ये तो डायरेक्ट साइड करता है ना किस डायरेक्शन में है ये डायरेक्ट साइड करता है ये तो जब मैं लर्न कर रहा हूं लाइन में लाइन ऐसे लेके आऊंगा वो इस तरफ 1 जनरेट करे इस तरफ 0 जनरेट
और वो जीरो दे
वो इस तरफ 1 जनरेट करे इस तरफ 0 जनरेट
अगर हम टेस्ट कर रहे हैं वो जीरो देता है वो 1 देता है
नहीं ट्रेनिंग टाइम में मैंने ऐसा मॉडल लर्न कर लिया है by just having ands and ors of the lines that has 0 error my final goal on every training point is 0 error सही है जी okay come up with the classification boundary for this you can use one line you can use two you can use 3 4 5 6 whatever start from 1 obviously you cannot do it start with 2
no I cannot
by two lines दूसरा नहीं होगा
तो सही होता
जरूरी नहीं है और पे है और पे भी आ सकते हैं नैंड पे भी आ सकते हैं कुछ भी लॉजिक कुछ भी लगा सकते हैं बाइनरी के ऊपर या not and XOR ये सब करता है. Okay, अगर ये हो रहा है या नहीं हो रहा, अगर 3 लाइन टर्मिनल हो जाएगा या 4 से हो जाएगा, eventually if you have a very complicated boundary, you can achieve it through multiple lines.
Yes.
Actually, combining the multiple lines or linear classifiers using ands and ors or logic gates using them, you can have a very different kind of boundary. Yes, no?
Yes.
That's the motivation. Okay. Assume this is a linear classifier. Assume this is a linear classifier. It outputs either 0 or 1. Make sense? And this is another linear classifier. It also outputs either 0 or 1. I want an AND of these. I want an AND of these. Yeah, I want a unit here that always report 1. Let me call this F3, which is made of like F1, F2. F3 will always give 1 if both of these are 1. Otherwise, it should give 0. Make sense?
Yes.
And the way F3 is implemented is the following. F3 में कोई input आ रही होगी यहाँ पे, F3 यहाँ पे total input ये. F3 में अगर value negative आई तो it will give 0. अगर F3 में value positive आई तो give.
अच्छा.
So F3 में हमें अगर value negative दे दी, F3 will output 0. So the threshold is on 0. F3 is just thresholding.
Yes.
Whatever is coming in, F3 is thresholding. So अगर negative value है तो output आएगी 0. अगर positive value है तो output आएगी 1. Make sense? So what you really have to do is the following. Supply F1. So F3 is just a threshold. Supply F1 की output and multiply this output with some value, let me call it W1. Multiply this with some value W1. Then supply the output of F2, multiply this with W2. Yes? Make sense? Then just add another value, let me call it W0. You are free to choose W0, W1, W3. Make sense? Then add them up. Here you add them up. Add all these products. So F1 times W1, F2 times W2 plus W0, add them up and feed this to this.
अच्छा.
And now it should give
0
1 if both are 1. Otherwise it should give 0. Tell me these numbers. W2, W1, W0. मेरे पास में आ गई?
Yes.
Okay. Tell me that. If this value, so this is just thresholding. So let me call it sine of whatever coming in. सही है? If this is 1 and this is 1, the value here जो पहुंचनी चाहिए वो positive आनी चाहिए. If one of these is not 1, then जो यहाँ पे value पहुंचनी चाहिए वो negative आनी चाहिए.
अच्छा.
You are free to choose W0, W1, W2.
W नॉट को माइनस वन कहते हैं.
W0 को -1 करते हैं.
W1 और W2 को 1 करते हैं.
1, 1.
1
No, then 0 will appear. अगर यहाँ पे 0 है, यहाँ पे 1 है, तो आंसर तो 1 आना चाहिए ना?
साइन पॉजिटिव आएगा तो F3 से
नहीं, 0 आ जाएगा. 0 का कोई साइन नहीं है.
-1 भी 0 है.
0 आ जाएगा.
तो
-2
-2 or -1.5 or whatever. -100.
ठीक.
Oh,
-100 -2 से ऊपर नहीं जाता.
-1.5. Is that okay?
Yes.
So let's see. If this is 1, this is 1, the answer here is
positive.
0.5. And 0.5 means this is 1.
Yeah.
Yes? Otherwise, either if this is 0 or that is 0 or both are 0, then the result here is
Negative.
-0.5 या उससे छोटा, which means the 0 is there.
Yep.
Yes, no. So if this is a binary classifier and this is a binary classifier, I've just made an AND gate using these two. Make sense? Yes, no.
Yes.
Now this is a binary classifier. We have 0 and 1. Yes? At the end of the day, this is giving 0 and 1. This is now a binary classifier. Yes?
Yes.
I can call this as a node test node. It is giving me some output. Yes? And there is another. It is giving me some output. I can combine these two together. That's my new classifier. ये बात समझ में आ गई? Yes, no. So far so good? अगर हर बाइनरी क्लासिफायर लीनियर हो स्टार्ट में सही है? So you can combine the linear classifiers using ands and ors and you can come up with a complicated boundary.
Yes.
At the end of the day, whatever you have done is a classifier. Yes, no?
Yes.
Make sense?
Yes.
Here is the motivation. Your logistic regression is what? Your logistic regression is the following. 1, x1, x2, this is the ith point. X, D, I. This is the ith point. This is multiplied by W0. This is multiplied by W1. This value is multiplied by W2. This value is multiplied by WD. All these things they add up. Yes? And then the result goes to this. ये जो सारा कुछ ऐड हुआ है, this is basically W transpose X add. Remember? ये result आएगा ना? This passes through a sigmoid. मैं बिल्कुल logistic regression को explain कर रहा हूँ. And then इसको आप threshold करते थे यहाँ पे by 0.5 and the value is either 0 or 1. That's your logistic regression unit. Make sense?
Yes.
और आइडिया ये था इस तरह के वेट्स लेके आए कि वो 1 को 1 पे मैप करें और 0 को 0 पे मैप करें. Yes, no?
Yes.
So using this logistic regression, अगर मैं इसको प्लस को और sigmoid को अगर एक यूनिट में कर दूँ ऐसे करके, okay, all this is going through a unit, and that is giving me, so this is S of W transpose X greater than 0.5. This is a binary classifier. Yes, no? I can have another binary classifier, another logistic regression module. I can have another one. I can combine these together. So I have another logistic regression. Let's say this is logistic regression. That's another logistic regression acting on the same input. It is giving it some. It has its own weights. यही इनपुट मैंने इस लॉजिस्टिक रिग्रेशन को भी दी, यही मैंने इसको भी दी. फर्क वेट्स के साथ. ये मुझे फर्क कोई आउटपुट देना है. It tends कि ये मुझे फर्क आउटपुट देगा, ये फर्क आउटपुट देगा. Yes? Yes. And then I use these as inputs to this. And maybe another one. Then I use these. And then might be at the end of the day, I have this. And this gives me 0 and 1. So this whole thing is just the combinations of different linear functions in layers. Yes, no? And now, with this analogy, you should be able to appreciate that this kind of network is much more powerful than a single logistic regression unit. You combine a lot of units, you have much more power. With one unit, you have one line. With multiple units, you have several lines. And you can combine the several lines in several ways. ANDs, ORs, XORs, and stuff like that. Yes, no? Yes. By the way, जब इसकी आउटपुट यहाँ पे जाएगी तो इसके साथ इसका एसोसिएटेड वेट होगा. जब इसकी आउटपुट यहाँ से जाएंगे इसका भी associated weight होगा and so on. Intuition कहाँ से आई थी इसकी और इसकी? असल में अगर आप ने दिमाग की कोई तस्वीरें देखी हों दादाजी में, तो जब दिमाग की तस्वीरें अगर आप देखेंगे तो वो कुछ इस तरह की लगेंगी आपको। इसमें काफ़ी सारी ना वेन्स या कुछ चीज़ें आ रही होंगी, इससे कुछ चीज़ें जा रही होंगी। जी थैंक यू।
कभी जरूर नहीं किया।
वो इस पे बड़ा ही अच्छा काउंटर कमेंट होता है। वो कुछ बात होती तो लगने लगता है कि बिल्कुल नहीं किया, उसने फौरन कहा आपका बनता भी नहीं। ओके
We can assume it's a brain. Okay.
सॉरी
We will assume this topic is a brain.
It's a brain.
Assume that it's a brain. Brain is here.
जो ब्रेन की वो कहते हैं ब्रेन के अंदर कंपोनेंट्स हैं दे आर ब्रेन सर्विस, ठीक है। वे व्हाट इज हैपनिंग इज दे कॉल दिस थिंग एज अ न्यूरॉन। देयर आर सम इनपुट्स दैट आर कमिंग इन द न्यूरॉन and then output is going out from the, so if I see one neuron, then one neuron is like this. मैं ये ऐसे करके बना रहा हूँ, लाइंस भी बना रहा हूँ because this is the physical event वो देखते हैं वो वेन्स ऐसे आ रही हैं and so on. And then there is an output, okay? And these inputs, this input is, I mean now this is a mathematical analogy of the brain. जो ब्रेन की तस्वीर को देख के उन्होंने सोचा है कि समझने की कोशिश की है कि ब्रेन कैसे वर्क करता है। लेट्स रेप्लिकेट द स्ट्रक्चर ऑफ द ब्रेन by hoping that this is how the brain is working, but that is just a hope. It is undiscovered fact. What they have mathematical analogy is the following: this is some input going into the unit. It is weighted by some number here. Then another input, it is weighted by another number, and so on. Then this is taking all the weighted sum, and if that sum exceeds a particular threshold, then the neuron fires. Otherwise, the neuron does not fire. That's the terminology in biology. Okay? Now, the firing input, if the neuron fires, it gives the output to the next neuron. And several other neurons, the same output is given to several other neurons. And now this neuron is taking input from the other neurons. Each of this input is associated with its weight. And now the weighted sum is calculated here. And now the neuron will be either fire or not fire. Then it moves on, and at the end of the day, you decide something. That's your decision that you make. Make sense? It is actually several neurons that are combined together, and this is called a neural network in the brain.
And all the weights are supposed to be independent of each other.
No, there is no dependence-independence notion here. These are some weights. I'm not associating the weights की distribution with respect to where each weight is independent of each other. There is a distribution or not. I'm not associating any of these for now. Make sense? What people think in neuroscience is this is how the decision process happens, and they want to replicate the structure. They want to replicate the structure that we may come up building these kind of machines. And maybe with some analogy that's how the human is thinking, and because human or a living being is a very good thinker, that's the maximum accuracy we can achieve. So let's replicate the structure. Make sense? उठाया उधर से structure है यार, इस तरह के कोई components होंगे वो ऐसे join हो रहे होंगे, but then they applied their math. अब वो कहेंगे अच्छा weighted sum हो रहा है, वो न्यूरोफिजिशियन के पास जाएंगे, वो कहेंगे कौन सा सम कौन सा डॉक्टर you don't know what is happening inside. I mean that's the structure, that's all we see. अब आपने क्या किया, वो स्ट्रक्चर उठाया, आपने कहा this is an input, इसके साथ एक रियल नंबर मल्टीप्लाई है, and that's how this neural network, that's why they are called artificial neural networks. they are constructed by just seeing the structure. But it turns out they are working perfectly with these kind of assumptions. They are not relatable that because this is working, that's how human is thinking. No. They copy the structure and they say that there are neurons and they are connected together, neuron fires and the neuron. For example, मैं देख रहा हूँ, this is the input that is coming in. जब ये input जा रही है, तो there is a layer of neurons जब ये input जाके लगती है, then those neurons process this information, give to the other neurons. Those neurons process the processed information, give to the other neuron, and then I predict what is happening and what is not. But that processing inside the unit, that is undiscovered. Make sense? How they replicate this, they said, okay, that processing is W transpose X. Let's work with this approximation. It turns out this simple approximation works extremely fine. Extremely fine in the sense it beats several other machine learning algorithms under certain assumptions. Big data assumptions, stuff like that. I will show you that. Yes.
So actually question is कि हमने जो starting में जो काम शुरू किया ना, हमने regression जो लगाई है, जो classification की है, sorry, classification तो हमने पहले किसी method से की होगी.
Yes.
ठीक है? हमने सिर्फ उन्हीं classification models को सिर्फ combine किया. हम ये नहीं कह रहे कि ये model से better है. Actually, it's a sort of composition of multiple.
So the theoretical answer is, if you ask me theoretically, is neural network the best classifier to date? Neural network, is this the best classifier of all the classifiers? My answer will be, I don't know. It depends upon the data. That's the theoretical answer. The practical answer. Well, neural networks is performing better on a lot of data sets as compared to the traditional classifiers. So in practice, it is outperforming. And here is why it is outperforming without going into the details for now कि ये work कैसे करता है. Why it is outperforming. This is a practical observation that SVM, your linear regression, logistic regression as a single units, all the classifiers we have seen so far and all the classifiers that are not neural network-like classifiers, they have a capacity of utilization of the training data. So for example, it is very good to have a lot of training data for a classifier to train very well. Yes? So you have a lot of training data, your boundary becomes very good and your test error becomes small and small. You have more and more training data, you can generalize very well. Yes? The hope is having more and more training data will scale the performance very well. It has a limit on traditional classifiers. So for example, if I just draw a picture and this